Hey guys, so this section is about quadratic functions, and it's kind of split into two parts. This first half is going to be about solving quadratics. The second half is going to go back to some of the graphing we saw in 1.5 and some algebraic methods for getting back and forth between sort of the two forms. The first half here we have methods of solving quadratic equations, and in general we want to factor. If factoring is available, that's going to be the easiest. And then after that, we kind of have these other three methods. Square root property is a bit limited. It's good for one little case of problems, but it's really good for that. I'll show you that in a second. Completing the square and quadratic formula, they both solve things that don't factor. You can just shove everything into the quadratic formula and it'll get you answers. You can complete the square on everything, it'll get you answers. But if you, and again, factor first if that's possible, because that's way easier than either of these. But if factoring isn't an option, then you'll get the easiest math usually if when a is 1 and b is even. And by that I mean there's the ax squared plus bx plus c. That's our form, standard form for a quadratic. So if this is 1, so it's just a plain x squared, and this number's even, usually the math is easier if you complete the square. And if you're terrible at completing the square, you're going to need it later in this section, and you're going to need it all over the next chapter, so you might as well get not terrible at completing the square. If a isn't 1 or b isn't even, then I would go to quadratic formula for sure. It's much easier to solve those ones this way. So I'll show both methods, and I'll show kind of where I would prefer to use them. But that said, if you're the person who just wants to shove everything in the quadratic formula, it works. I'll do an example where I do it both ways and kind of show you my preference, but that does work. Okay, so first up we have the square root property of equations. And that says if I have a square equals some value, I can take the root of both sides to undo the square, and that solves the equation essentially. This plus or minus is because, say I have x squared equals 25. So 5 times 5 would make 25, but negative 5 times negative 5 also makes 25. So when we apply a square root to both sides of an equation, we have to do that plus minus to account for that there's two possible solutions. So for this first one, I'll just root both sides of this. So that's going to give me square root into square. And I should probably stop there and point out, so we saw this in the inverse section, but roots and powers go together, so we can always undo a power with a root. But when we do with this one, we have to plus or minus square root negative 64. And then remember negative 64, so what that's going to do is get us imaginary numbers. So this is going to be x equals plus or minus 8i. For this next one, it's not quite in the form, but if I subtract the 20 off of both sides, then it will be and so then I can root both sides and get x equals, so plus or minus square root 20. Remember 20 is 4 times 5, so I'm going to need to simplify my radical a little bit. So this is the thing where it's like negative 4 times 5 under there, so I get the negative is going to bring out the I, the imaginary part, and then the 4 comes out as a 2, and then the 5 has to stay inside the radical. So that was square root property. So for these next two examples, I'm going to do the same problem, but I'm going to do it once using the quadratic and once completing the square. So the first step is the same either way. In both these cases, 2, 28, and 38, they're all divisible by 2, so I'm definitely going to knock a 2 out of both of them. And so now these are 2 into 2 would make an x squared, 2 into 28 would be minus 14x, and 2 into 38 is 19 equals 0. So that is what we're working on. And so first I'm going to do this by quadratic formula. And the quadratic formula, I'm not sure this will be big enough for you to see. I'll bring it up like this. Yeah, that's better. So quadratic formula is given something in the form ax squared plus bx plus c. If you very, very carefully solve this for x, and it takes about half a page, it's kind of a pain in the butt, and you do it by completing the square, this method up here. But if I solve this thing for x, then this is the result. So for any quadratic, if I want to solve for x, I can just plug into this side and it's going to give me the solutions. And that's for when the output is 0. So what this is really doing is finding x-intercepts. So I'll come down here and I'm just going to plug everything in. I think do I have enough room? Yeah, I'm just going to do this, x equals, so the first thing is negative b. So, and on this, my a is 1, my b is negative 14, and my c is 19. So negative b, so that'd be the negative of negative 14, and then it goes plus or minus square root of b squared, which is negative 14 squared, minus 4 times a is 1 times c is 19. All over 2a, so 2 times 1. And so that's pretty much it, and I just have to successfully clean that up, which is a little bit, could be a little bit challenging. So this will go x, negative 14 is 14, plus or minus, negative 14 quantity squared is 196. A really common error is to go negative 14 squared in your calculator and not put the parentheses, and then it tells you it's negative 196. So this can never be negative because you're squaring the whole number, not just the 14 and then making it negative. So don't believe your calculator, this should be a positive. And then minus, actually believe your calculator, but type with parentheses would probably be the better thing to say there. So then 4 minus 19 is going to be 76. And then that's all over 2. And then cleaning that up, I get x equals 14 plus or minus 120 over 2. For the sake of space, I'm going to be sloppy over here and say that 120 is 4 times 30. And so coming down here, this is going to be 14 plus or minus, I can take out the 4 as a 2, root 30 over 2. And then the last thing is, if you look in these 3 spots right here, here, and here, so not under the radical, because that's not a real 30, that's a square root of 30, totally different game. But the coefficient of that, if all of these 3 have something in common, that means your fraction needs to be reduced. So in this case, everything is divisible by 2, so I'd go 2 goes into 2 once, 2 goes into 2 once, 2 goes into 14 7 times. And so I won't write this over 1 because that would look silly. So my answer is going to be 7 plus or minus, and then we don't usually write that 1 in front either, so it'll be just root 30, but invisible 1, invisible 1. Cool, so that was the quadratic formula, and it gets a little dicey right in here, getting that radical reduced, and then that reduction. So like on exams, that's where I see people tend to make some errors. And then just be careful with your signs as you're plugging in. That's kind of their spot. So there's pretty much every spot, there's places to make errors. So now I'm going to do this by completing the square. I'm just going to copy this one down over here. Okay, so that's what I'd be working on. For completing the square, it has steps, and I think that's why people don't like it, is because there's like you don't just plug into a thing and grind it out. You kind of have to know where you're going. So the first step is to bring the constant term over. The second step is if a is 1, divide through by a, but I already did that right here when I reduced it. And so then we get to the magical step after that. So first, let me bring this 19 over. Now just leave a little room because we're going to add something here in just a second. So that'll be a negative 19. And then here's the magical step. It's not really magic, but people think it is. So it's where we take half the middle term, or half of b, we square it, and we add that result to both sides. So what we're doing is we're taking half of 14, and that would make 7, and then we square that, and that would make 49. And then that's what we add onto both sides, and I'll explain why in just a second. I think let me finish the problem, and then I'll explain this step at the end. So then next is we do factor to a plus b quantity squared or a minus b quantity squared, depending on the sign. So ours is a minus, so that will be x minus 7 quantity squared equals 30. And then solve using the square root property of equations, which was this thing up here that says if I have a square, I can root both sides and solve. So then here, we got square to undo, or sorry, a square root to undo the square. Same thing here with our plus or minus. So these knock each other out, and we have x minus 7 equals plus or minus root 30. And then last I can bring that 7 over. So x equals 7 plus or minus root 30. So there's the trickiness of this, of kind of having to remember what to do. With the quadratic formula, you know, you get the formula for the test, so you can just kind of plug stuff in there and grind it out. But people often kind of get into trouble somewhere right in here. This was a lot easier math. I didn't have to think so hard as I was doing this. But it does have these steps to remember. So that said, you actually are going to need this for, like I said, 3 sections coming up. So if you didn't make friends with completing the square in 98 or 95, now is the time. To explain how come this step works, just briefly, what we need this to do is to turn into something that is of this form. And like I said, it could have been a plus if this happened to be a plus. These come from quadratics of the form a squared, minus 2ab plus b squared. And so what I have here is not this. And so what I'm doing, what the completing the square is finding this square. That's the completing it part. That will make it factor like this so I can solve it. And so that's why we get the 19 out of the way. And we do half of 14 to knock out the 2 in the formula. So the half undoes the 2. And then that leaves 7, which is b. And then we square that. That makes the 49 that makes it factor to this. So that's what the magical third step of completing the square is. It really is one. If you're equally good at both methods, this is nice. This doesn't have as many places to mess up as this does. So I encourage you to get comfortable with both methods. Okay, in this next one we got some fractions going on. So the best thing to do with that is to get rid of them. So I'm going to multiply both sides by 6. And so what that'll do is knock out the 3 and the 6, but you gotta make sure you get the x here too. So I can go 2/3 of 6 is 4x squared, or you get to go to 12 divided by 3. 6 times the negative x, so negative 6x. And here the 6's would cancel, leaving the negative 1. And then just writing that with the 1 over on this side. 4x squared minus 6x plus 1 makes 0. A is not 1, so I definitely do not want to complete the square because I'd have to divide that 4 through, and then I'd have a bunch of fractions everywhere. So here we have A is 4, B is negative 6, and C is 1. And so I'm going to plug them in a little bit faster this time since I kind of talked through on that last example. So this will be x equals negative of negative 6, which I'm just going to write 6, and then plus or minus negative 6 squared minus 4 times A, which is 4, times C, which is 1. And then that's all over 2A, and A is 4. So then we get x equals 6 plus or minus 36 minus 16 all over 8. And that's going to be x equals 6 plus or minus square root 20 over 8. 20 is 4 times 5, so that means I have to reduce that. So x equals 6 plus or minus, the 4 will come out as a 2, because square root 4 is 2, root 5 over 8. And then this one reduces, and so remember, if we have the same stuff here, here, and here, and there's something divisible, and this is all divisible by 2, so then we have to knock a 2 out of there. So 2 goes into 2 once, 2 goes into 6 3 times, and 2 goes into 8 4 times. So we're just reducing everything by a factor of 2. I don't have to reduce the 5 because this is a unit. So it's like if this was 10, I would have just knocked out a 2. So it's totally okay as they're multiplying. So final on this is going to be 3 plus or minus root 5 over 4. For number 6, we're going to have to do a little bit of FOIL and then incorporate this 4 over, and then from there we can see where we end up. But already this is turning into, it's not going to lead with a 1 more than likely, so probably going to be quadratic formula. So 4x squared minus 2x minus 6x and plus 3. And while I'm here, I'm going to bring this 4 over, and that would equal 0 then. And then 4x squared, that makes minus 8x, and then plus 7. So definitely quadratic formula for this one. So we're going to have x equals negative 8, so that's 8, and then plus or minus negative 8 squared minus 4 times a times c all over 2a. And then cleaning this up, we get x equals 8 plus or minus 64 minus 16 times 7 is 112 all over 8. X equals 8 plus or minus. This comes out to negative 48 over 8. And then I think I'll scoot up here with it. X equals 8 plus or minus. And 48 is 16 times 3, so, and also negative. So I'm going to bring out, actually I guess I'll just write that up here. Let's recopy it since I didn't bring anything out. So x equals 8 plus or minus, now I'll bring out my 4, the negative brings out an I, and 3. And this one also reduces, everything is divisible by 4, so we'll go 4 into 4 once, 4 into 8 twice, 4 into 8 twice. So that gets us x 2 plus or minus I root 3 all over 2. Okay, so the second half of this chapter is about quadratics, graphing them, and so like I said, it kind of goes back to 1.5 graphing, and then we're going to get a couple of different forms. So there's standard form, I'll bring this up a little closer, which is this one that we're just working with like when we're doing the quadratic formula, and then there's vertex form, which is this one, which hopefully looks familiar from 1.5. We didn't have the H and the K and the A, we didn't really define it that way, but this is the same shape as all those transformations that we saw in the first chapter. And so when something is in this shape, what that is remember how this was our left-right shift and this was our up-down shift. So if this is left-right, that was where our X went, and K was up-down, so that was where our Y went. And so remember I used to start at 0, 0 on these, and I go over 3 and down 2 or something to negative 3, 2. What that point is called is the vertex. And so, and it's represented right there in the formula. And we're doing that all the way along using the transformations, but now we're just going to sort of define it as the starting point and give it a name. Axis of symmetry. So an axis of symmetry is like, if you think of what the parabolas look like, they're kind of U-shaped. If I folded it over and right on top of itself, then that's the axis of symmetry, and that's going to be x equals the x-coordinate of the vertex. In standard form, so for this we have a formula, and it's the first chunk of the quadratic formula, actually. It's the negative b without the plus or minus. That plus or minus gets us the x-intercepts. This gets us kind of the midpoint of the x. So if I go to find the x-coordinate of the vertex from standard form, I can just do negative b over 2a and plop in my a and my b, and that's going to spit out the x-coordinate. I can plug that in for x, which is what f of this means, and then that spits out my y-coordinate that goes with it. So this gets us x, we plug that back in, and that gets us y. And then axis of symmetry is still equal to the x-coordinate, so it's going to be x equals the negative b over 2a, same as the x-coordinate. Couple of little notes here on parabolas. If it opens up, a is greater than 0, that's a reflection. And remember, if it was a is less than 0, the number in front means it has a negative, so it's going to open down. And to find x-intercepts, we let y equal 0. To find the y-intercept, we let x equal 0. So those are kind of the pieces we'll be looking at in this section, or the second half of the section. So for this first example, we're actually given the formula in vertex form, and we're asked to find the vertex, axis of symmetry, intercepts, and graph. Okay, so we have, I'm just going to write this down here. So f of x equals 1/2 x plus 3 quantity squared minus 2. So if we think about this the way that we saw in 1.5, this would be, it would go left 3 and then down 2. And that would be like my starting point on the graph. What we're looking at in this section is this HK. Something to note, remember how here plus went left, which was kind of counterintuitive? So that is showing as negative h, or the opposite of h. So h will always be the opposite of what's showing, and that's that same kind of backwards left-right thing. So if you have a plus 3 here, when you go to write your hk, that means that this is negative 3, and then the up-down still makes sense. Minus is down and plus is up. So negative 3, negative 2. And if you thought about plugging this back into this formula, that makes make a little more sense, because if this is negative 3, I plug it in, I get x minus negative 3, which is x plus 3. So it has to be opposite sign of what's showing on the x. So this is our vertex. Axis of symmetry. Always equals the x-coordinate. So that's going to be x equals negative 3, and I'll show that when I draw the graph. Okay, I'll do the y-intercept first. So I'm going to say y equals, so f of x, I'm using y because we're going to graph 1/2 0 plus 3 squared minus 2. And so if I let x equal 0, then that means that's going to be my y-intercept. And I just have to clean this up, which is not that nice. So 3 squared would be 9, and then minus 2. So this would be 9/2 minus 2. And then we'll do, oops, 2 over 2. So that would be 9/2 minus 4/2, or 5/2. So my y-intercept is x is 0, y is 5/2. And my vertex was back there. Axis of symmetry right here. And then I also need to find the x-intercept. So if I'm doing that, I'm letting this side equal 0. I'm going to complete the square. I'm going to finish completing the square because it's already basically completed. So I'm going to write it with the 0 on this side just because it seems more natural to me. So 1/2 x plus 3 quantity squared minus 2 equals 0. Remember, if y is 0, that puts us on the x-axis, so this gives us our x-intercepts. First I'll add the 2 over. And And then next I'm going to clear this fraction. So I'll multiply both sides by 2. And I get x plus 3 quantity squared equals 4. And then I will root both sides. So that's going to give me x plus 3 equals plus or minus 2. And it's a little bit tricky with the number that works. What that means is you have negative 3 plus or minus 2. And those are actual plain old numbers. So if I have x equals negative 3 plus 2, that's the same as x equals negative 1. And then x equals negative 3 minus 2, that's going to be x equals negative 5. So that's going to give me x-intercepts at negative 1, 0. So not negative 1, negative 5. These are both x's. And negative 5, 0. So then graphing all the stuff I just found, we'll start with the vertex right here. So that's right there. And then negative 1, 0. So that'd be right here. Negative 5, 0. That's right there. And right there I have a pretty good, I got my 3 points, and that's all I need for a quadratic. And so this is going to look something kind of like that. As for my y-intercept, it wasn't a very nice number, so I didn't use that as one of my points, but if you look, it's right there. And then the axis of symmetry, remember x equals is a vertical line. We'll see those a bunch at the end of the chapter. Lots of asymptotes coming up. And so this is an asymptote. This is x equals negative 3. So this is the axis of symmetry, which is to say if I took this and I fold it over on that line, then the parabola should be sitting right on top of itself. Okay, so for number 8, it's asking us to take this, find the vertex, axis of symmetry, intercepts, graph, and write the quadratic in the vertex form, which is that the form we just saw. And so for this one, I'm going to use the negative b over 2a, and that's going to let us find the x-coordinate of the vertex. I can plug that back into the formula and get the y-coordinate of the vertex. And once I have that, I'll still have to find the intercepts, but that will get me on a good start for, I'll have my vertex, I'll have my form here, and I'll have my axis of symmetry. So starting with the x equals, so negative b over 2a, I'll just write that there. And that would be negative of negative 4 over 2 times negative 1. So we got 3 negative signs, so that's going to be negative, and then 2 goes into 4 twice. And then once I know this, I can plug that in, and so then my y-coordinate, so I'm finding f of negative 4, but I prefer this for, like I said, graphing, would be negative of negative 2 squared minus 4 times negative 2 minus 3. So I'm just plugging this back into the original. Hardest part is being careful with the signs. So that's 3 negatives right there. So that's going to be a negative 4. Oops, we get equals in there. 2 negatives, so that's going to be positive 8. 1 negative stays negative. And let's see, that'd be negative 7 plus 8, so that should be 1. So my vertex is going to be at negative 2 and 1. So that's vertex. Let me get my intercepts, and then I'll do the graphing and the making the form. So to do the x-intercept, I have to let y equal 0. So that would be negative x squared minus 4x minus 3 equals 0. Don't love that everything is negative, so I'm just going to multiply both sides by negative 1 and make this a little bit easier to work with. So that makes all these positive, which will give me less signs to have to keep track of. And it also makes it where I can say I can factor, so I'm just going to factor to get there. So x plus 1 and x plus 3. So here we have x equals negative 1, x equals negative 3. So those are going to be my x-intercepts. And again, those are negative 1, 0, negative 3, 0. Lots of times people graph negative 1, -1, -3, and make a point, and those are both x's. So remember, we let our y equal 0. To find our y-intercept, much easier from this form. So now we just say y equals 0 squared minus 4 times 0 minus 3, and it's always this number on the end in standard form. So y equals -3, and that is when x is 0. So there's our y-intercept, there's our x-intercepts. So let's get this graphed. X is -2, and y is 1. And then I have a y-intercept down here at -3 that I can use. And I have the two x-intercepts. So -1, 0, and -3, 0. And we know parabolas are symmetrical, so I'd have another point right there. And you can see if we're getting the over 1, down 1, over 1, down 3 that we saw in 1.5. So this should look kind of like that. Axis of symmetry is going to be right there. So that's x equals -2. And then to get standard form, so whatever is in front here is going to be a. So let me start this here. F of x equals, so a is going to be that negative, and you can think of that as -1x squared. Actually, no, don't think of it that way. As I'm thinking about it, just think of it as a negative, because we wouldn't really want to write the 1 there, but it's an invisible -1. This is x minus h, and this was our hk right here. So x minus h would be, strictly speaking, like that, and I'll clean up that little sign on the next thing, but I just want to show where the sign change comes from. Because remember, the formula is x minus h, so with the -2 in there. And then plus k, so that's plus 1. So making this look a little nicer, I got negative x plus 2 quantity squared and plus 1. Okay, so for this next one, same steps as last one, just a little bit different equation. And this time the intercepts are going to be not quite as nice. So to get the vertex, I'll do x equals -b, so -8 over 2a, 2 times 2. So that's -8 over 4, or -2. And I'll just plug -2 back into here and get my y value. So y equals 2 times -2 squared plus 8 times -2 plus 11. So that's going to be 8 minus 16 plus 11, or 19 minus 16, so that makes 3. So my vertex equals -2, 3. My y-intercept is the easy one. So the y-intercept, if x is 0, it knocks out these two pieces, so that's always going to be the y-intercept on the end. So that's going to be at 0, 11. Axis of symmetry is going to be at -2. Get that one down. And then that leaves the x-intercepts, which are not too nice, because if I tried to factor it, I'd go 2 times 11. There's nothing that multiplies to 22 and adds to 8. So that means I need to do the quadratic formula. So x equals -b, -8, plus or minus b squared minus 4 times a times c all over 2 times 2. So this is -8 plus or minus 64, and then this would be 8 times 11, or 88. And right there, I can see this is going to be negative, and so that means I'm going to have an imaginary solution. So what that means is there's no x-intercepts. And so our parabola is going to be, in this case, above the x-axis and opening up. It could also be below the x-axis and opening down, and so, but that's what it'll look like when you try to solve. So then for the graph, oh, actually, before we do that, let's get f of x written. So f of x equals, so again, the thing in front of the x squared, that's going to be your 2, and that's going to be your a right here, and then x minus the x-coordinate, so minus -2 is plus 2 squared, and then plus 3. And so I think this time, since I don't have a y-intercept that fits on my graph or x-intercepts, now I'm going to go back to my transformations and get this graphed. So vertex is -2, 3, and that's our left 2 and up 3. And then because of this 2, that means instead of going over 1 up 1, it goes over 1 up 2. And that's that stretch by a factor of 2 that we saw in the first chapter. And there we go. So this one doesn't have a graphing supplement with it, but you can review the graphing in section 1.5. Okay, and this last question is given, it's actually a lot like the find the equation of a line given the slope and a point. So for the quadratic, it's given the vertex and a point, find the equation. So it's kind of similar to those linear problems. So we have a vertex right here. I'm just going to jot that down over here, and that is h and k. We have this point, 4, 3, that's an x and a y. And then we have this formula, which I'm going to, instead of f of x, I'm going to write it as y. And so that would be y equals a x minus h quantity squared plus k. So we know y, we know x, or we know a y and x that we can plug in, and we know h and k. So the only thing we don't have is a. So if we have these 4, we can solve for a. So our y is 3, a is what we're looking for, x is 4, h is 3, quantity squared, and it won't matter because it's 1, and then minus 1. So then 3 equals, 4 minus 2 would be 1 squared is 1a minus 1, and then just bring the 1 over, and we have a equals 4. So same as when we found equation of a line, then we had to write it down with the slope and the intercept. Now we'll just write it down with the hk and the a. So our equation would be y equals the 4, and then x minus the h, and then plus k, but k happens to be a -1. And that wraps up that very long section 3.2.